session of welcome to IEEE-GRSS, the Geo Remote Sensing Society. We're a real exciting session for you today. Thanks for joining us. Those of you who are over in sessions, we've got our speaker with us now. We're really glad to have you over here on the main stage.
Great. Thank you, Nancy. So I'm Dave Kunke of I'm the 2023 GRSS past president, the Geoscience and Remote Sensing Society of IEEE. And I'd like to talk with you today about a few items about remote sensing and what we do, what are some of the disciplines within the society, and how you can connect with some of the industry that supports space-based remote sensing as well. So what is remote sensing? Well, people in the society, we design and utilize instruments on satellites, airplanes, and ground to gather information about the Earth's atmosphere, oceans, and land, in short. And that involves, sensor design, data manipulation, data analysis, a lot of Earth science, and also a lot about aerospace engineering. And it's a cross-disciplinary field, and that's what I really appreciate about remote sensing, and also that it involves an international network really to share the data and develop, really to develop a very complete picture of our Earth from a geophysical point of view. And that's through weather forecasting and climate studies and a lot of other information that we find out about, both regional and how the Earth is continuing to change. So remote sensing affects you in ways that you may not realize by informing weather forecasts and disaster areas, crop yields, land use, and much more. As I mentioned earlier, remote sensing allows for a very synoptic view of the Earth. So for instance, from space, we can not only look at hurricanes, track hurricanes, gather the information needed to understand the development of the storm, but we can also look inside the storm and for the internal structure to understand how it may, how strong it may be getting, and general forecast values. So just an example of some of the sensor imagery that we use kind of on a daily basis. This is a space-based microwave sensor that detects rain bands in Hurricane Ian. This was a hurricane, I believe, last September. That was in the Caribbean. And we look at these images to understand how the storm is developing, and how not only to track the storm, but to understand its impacts when it hits landfall. Space-based remote sensing does a lot of the heavy lifting when it comes to understanding the tracks and understanding the storm evolution. Also, I'm sure that you're familiar with ground-based radar to determine the intensity of thunderstorms. We can use Doppler radar to understand, where the fronts intersect, or where there's a lot of dynamics within the storm. And so this is another area, is also ground-based remote sensing. One of the things that we do with a lot of exquisite sensors in remote sensing is to understand man-made emissions from the Earth's surface. And this informs scientific models of the Earth's surface and atmosphere, and such as the role of water in the environment, and also pollution and emissions from cities, and how their transport in the upper atmosphere can affect the Earth's radiation budget, and also global climate change. So there's lots of aspects to the sensors which we design and field and use. One of the biggest aspects of this is keeping track of the global hydrological cycle. We create global maps of precipitable water and cloud liquid water are two of the staples of remote sensing, particularly microwave remote sensing. And another characteristic is that of the atmosphere. So we can look at, create vertical temperature profiles within the atmosphere. We can look at water content within the atmosphere, and also see if you live in Southern California, sometimes you're familiar with the Pineapple Express, the water that comes from from Hawaii and causes rain in Southern California. You can see this if you can see the mouse. These paths of the water content in the atmosphere shows up. Is very sensitive to the frequencies we use are very sensitive to this to the water in the atmosphere, and we can track that using a variety of measurements from space. So this informs global numerical weather prediction models, as well as long-term climate models. And so some of the prominent specialties, I know that the purpose of this conference is really to connect with industry. And what I've mentioned about remote sensing is that it's multidisciplinary. It involves, microwaves and antenna design if you're working with microwave sensors. If you're working with optical sensors, detectors, optics, focal plane arrays, microelectronics. So a lot of engineering disciplines plus aerospace engineering, really to design the orbits, the space vehicles, and the sensors and missions. But a big part of working with remote sensing recently, when I joined the society and started working in the field in the 90s, it was all about making bigger and better sensors. And we were still developing some of the, applying the technology, and we're still doing that today. But with the advent of commercial space and easier access to space, there's been a lot more commercial involvement in remote sensing and fielding of not only sensors but also intellectual, IP specialized data analysis of the information that we have. And that's continued to grow within the field. And so, dealing with hyperspectral data, multitemporal, big data, bringing together data sets with drastically different spatial resolutions, such as microwave measurements that may have 20 or 30, 40 kilometer footprint size compared with 375 meter resolution from some of the Viz and long wave sensors, as well as multi-temp, looking at the same area multiple times during the day. You can create lots of information from various data sets, and data analysis has become probably more than, I would say, more than 50% of the activities within the society. And then, of course, earth science plays a large role as well, understanding the various regions of the Earth, cryosphere, atmosphere, oceans, and land. So it's a really confluence of both earth science, pure sciences, and some of the pure sciences as well, and engineering, sensor engineering, aerospace engineering, and a lot of data analysis thrown in. So really a very wide range of contributions you can make to remote sensing. And it's very important, obviously, there's been a lot of interest in improving the weather forecasts to better predict the impact of storms and disasters, but also, of course, climate modeling. And that's been in the news and will continue to be an important thing going forward in the next decades. So we've really noticed the resurgence and growth within the society. The society has grown to something like 5,000 members now, a steady growth over the last couple of decades. And that's just due to the interest in climate modeling and understanding the Earth as a system. So let me talk a little bit about the society. The Geoscience and Remote Sensing Society is a technical society of the IEEE, and it fosters engagements among our members for the benefit of science, engineering, and applications, and for the further development of geoscience and remote sensing. So we're a group of scientists and researchers with a common interest in a common framework. And so what we do is we have we sponsor 4 refereed publications. We sponsor about 12 or more conferences, specialized conferences during the year. We have several professional activities, including awards, young professionals, and mentoring activities. We have education. We put courses in remote sensing on the IEEE Learning Network and offer a lot of tutorials through the web. And then we have technical activities highlighted by our 7 technical committees with hot and developing areas within remote sensing. And we also have a standards activities standards committee now. And we do many things, but it's really about the people. We have now, I think, 112 combined chapters between our regular branch, our regular chapters and joint chapters, and our student branch chapters, as well as ambassadors in areas which we're trying to develop chapters. So again, we're a worldwide, a global community, but we really like to think of ourselves as a community of community, providing connections through live webinar series, web workshops, TIE events, which is a special track associated with just hot topics in remote sensing, as well as industry speakers at our conferences. By the way, our next flagship conference is in Pasadena in 2023 this year in July, and we hope to see some of you there. IGRS creates a forum for both the fundamental aspects of remote sensing through sensor engineering, all the way up to the mission level and the roll up in the application of the sciences. So all aspects of remote sensing are represented. And it's our flagship event every year in the summer. We also support our student community through continuing education, GRS schools. We have a resource center and a learning network and a young professionals community, where we have a mixers and social media team. If you're not familiar with some of our social media channels, talk to me afterwards and we'll get you connected. But really we support the global research community through networking and leadership in publications, conferences, awards, technical activities, and information resources. So we disseminate premium science through our 4 journals, as I mentioned, Transactions, Letters, and Applications, as well as Remote Sensing Magazine, which has, I think, the highest impact factor now of most publications in remote sensing, plus a journal in which we collaborate with other societies on miniaturization of air and space systems. So again, science and engineering aspects of remote sensing. So what we can do for the community is support continuing education of students, support problem solving, help by connecting companies and young motivated people, and connect the different companies of the Earth observation practitioners and researchers to make everyone aware of the most up-to-date information, either via our newsletter, GRSS magazine, or our website. And please take this as an invitation to join our community. We can help you share and promote your ideas, meet with and communicate with other communities and gain from their perspectives. We can help build collaborations. We can help learn from each other. And what I like most about GRSS is the ability to really work with like-minded researchers and developers to make a difference in the world through remote sensing. In that way, we can support the IEEE mission of technology for the benefit of humanity. And that's the real message I had this morning. And just to relate to the Eta Kappa Nu, I joined Eta Kappa Nu through the Beta Psi chapter in 1982, 41 years ago today. So I'm happy to be here and to present and to answer any questions you may have about the society or remote sensing in general. So thanks for your attention.
Well, David, that is a beautiful HKN plaque.
Thanks.
So I know some chapters, some students make those today, but I've been in many people's offices, very accomplished professionals like yourself, and they have their Eta Kappa Nu plaque prominently shown. So that's kind of a fun thing.
I did have to find it for the last presentation, but yeah, it was a big event making those and getting to know the other students within the pledge class.
So let's see if we have any Q&A coming up here. So questions, but I know we're a little short on time because we have some technical difficulties. But I don't know, David, if you have some time, if you want to jump over to your booth or you want to be there later, people can leave questions there. How else can they contact you, David, or contact GRSS?
So we have a website which I didn't put the address here, but this is IEEE-GRSS, and it is a society of IEEE, and so that's really the key search. Let's see, IEEE-GRSS.
Mm-hmm.
So,
yep, there it is. I'm going to get a picture of that for myself, David. So that's great.
Yeah.
So if any of you are looking for, certainly on the IEEE website, you can look up all the technical societies. There are 42 of them, and GRSS is really an amazing society. I think it's so cool what you do. When I first saw it, I went, GRSS. And I said, wow, look at all the stuff that's involved with that. So that's really cool. So
yeah, one of the great things is that we work with the international research community, both in ESA, the European Space Agency, JPL, NASA, and Goddard are where we draw a lot of our members, and so you get the perspective of the latest science. So.
Yeah, and I think that's what's exciting, right? What you said, meet with like-minded people, but people who are really doing the cutting edge, interesting, super duper stuff that that does impact us. I mean, it's not a small thing; it's huge.
And just because I know that there's many from a young person's perspective. I was in theoretical electromagnetics for several years, studying antennas. I learned engineering, or I was exposed to radio and some of the science aspects pretty young, and developed some skills with radio even before I entered undergraduate school. And when I got into graduate school, I was kind of interested in pursuing that through electronics and antennas. But what I really found in remote sensing that was exciting was the application. And I was enthused. I really did want to do theoretical, foundational work, but through remote sensing is very, very exciting, and it was a more developing field than some of the other mature fields, and so a lot easier to make contributions in. And I've always appreciated that about remote sensing, still to today, and just being at the forefront of some exciting areas that people talk about a lot, such as how the world is changing, and the implications that it has for the future.
I mean, definitely, this is not just a small thing, right? This is integral to all the other sciences as well. So I think that's what's great about our technical societies, and particularly about your society, is really how do you go and find people that are doing that which you want to do, or where do you go learn from? Because lifelong learning, right? This is not, you learn it and you're done. You're not done learning when you leave university.
Right, and that's one of the most important things about engineering, and that's really what the societies. That's how it's one of the major ways that societies serve the profession, is by keeping you current. And from my own experience in working with the U.S., I have pretty good access to U.S. research and U.S. activities, but through the society, it's really international. And the remote sensing is a global activity. I mean, the climate change and weather is done through global measurements, and you really have to involve everyone. And so that's really what I've appreciated about the experiences that IEEE gives us.
Well, thanks so much for sharing a little bit about your personal story and what you've gained from it, because I think that should give inspiration to others joining us and others who watch this session later. Certainly glad to talk about GRSS, and we hope to be with you in Pasadena, so we'll talk about that too. And, again, celebrate HKN, but really bring more people to understanding what the society is, what you can learn, what you can do, how you can benefit. So please check out GRSS. Go visit their booth if you have a chance. I know they want to hear from you. And coming up next in our Pathways Day 2 is going to be a session with John Deere, growing technical skills outside the classroom. So I hope you'll join us over in sessions. And then later today, like I said, there's going to be the recruitment fair at 3 to 4:30 and a keynote address at 12 o'clock on with the father, someone who's kind of regarded as the father of the Arbitron rating system, the Nielsen rating system, which is the beginnings of AI and ML. Very cool stuff. Thank you so much, David. Thank you for your support.
Thank you, Nancy, and Mehmet.
And Mehmet, yeah, actually, Mehmet, thank you so much. I love working with all of you. Take care, and we'll see you around the conference.
Yep, thank you.